we're going to do a very quick recap of multiplying and dividing by 10, 100, 1,000, etc. We did look at this when we did fractions, so it's just a quick recap. So remember, we looked and we said if we did 5 times 10 is 50, 50 times 10 is 500. What we're seeing when we're multiplying by 10 is we're not changing the digit, we're just changing its place value. So 5 was in the ones, now it's in the tens, then it was in the tens, now it's in the hundreds. So all you want to do when you multiply by 10 is change the place value. And it's tempting to just say, okay, we just pop a 0 on the end to change the place value, and that's fine as long as you're dealing with whole numbers. But of course the problem comes is if you've got 0,5 and you multiply by 10, if you try and use that rule of just pop a 0 on the end, you're going to just put a 0 on the end here and you're going to say it's 0,50. And then you actually haven't changed the place value. In fact, you haven't changed anything at all, because 0,50 and 0,5 are exactly the same thing. You've got 5 tenths, and here you've got no hundredths, but here you've also got no hundredths. So popping a 0 on the end doesn't work very nicely when you get to decimals. And so what we said is, instead, what we're going to do to change the place value is move the decimal comma over to the right to make the place value of the 5 bigger, and so you'd end up with 5, 0, which is just 5. So if we want to do something like 0,23 multiplied by 1,000, we've got to move the place value over 1, 2, 3, and so what we're going to do is we're going to move the comma, and we're going to move it 1, 2, 3, right, and put a 0 in there, and so we get 230 as our answer. If we want to divide by 1,000, this is just going to require us to make the place value smaller, and so we're just going to move the comma in the other direction, and again 1, 2, 3 lots of 10, so we're going to move 1, 2, 3 lots over, put the comma there, and we'll fill in the zeros, and so we get our answer is 0,00023. So multiplying and dividing by 10 is very simple. It's just a case of changing the place value, and the easiest way to do that is by moving the comma. Let's have a look at scientific notation as a way of writing really big numbers. On this page we have 4 different ways of writing exactly the same number. So all these 4 are exactly this number. Now this number, a good old normal old number, we're going to call it being written in standard form. When we write it like this, we're going to say it's in scientific notation. Take note, for scientific notation, we need to have just one digit before the comma, and that digit can't be 0. So it must just be one digit before the comma, and that digit can't be 0. So this is that number written in scientific notation. This is a perfectly decent way of writing that number, but it isn't scientific notation, because although it's got a digit before the comma, that digit is 0, and we said it had to be a digit that isn't 0 before the comma. And again, this is another way we could have written this, but it isn't scientific notation because it has 2 digits before the comma, and for scientific notation we only want 1 digit before the comma. Okay, let's look quickly how we would move from one form to the other. So if we've got this form here, we have written it in scientific notation, we want to turn it into standard form. So all we need to do is we need to go and multiply out 8,572 by 10 to the power of 6. And when we do that, we're going to move that comma 1, 2, 3, 4, 5, 6 places, right? And we'd have to put in zeros for all those. And so what we'll get is 8, 5, 7, 2, 0, 0, 0. The exact reverse is what we'll do when we're trying to get it into scientific notation. For scientific notation, we know we want to get it into the form 2,95 times 10 to the what? Well, how do we get back to 2,95? 1, 2, 3, 4, 5 places to go back. So it's 2,95 times 10 to the 5. We're going to have a look at how we can write scientific notation for small numbers. We have two numbers here that are written in scientific notation. They have a single digit before the comma. But the difference here is now you've got the exponent being a negative. How does that change things? Well, we know what a negative exponent means. This means 3,21 times 1 over 10 to the 4. And so actually what we have is 3,21 divided by 10 to the 4. So let's take 3,21 and divide it by 10 to the 4 to see what we get out as our answer. So dividing by 10 will move the comma there, and then another 10, and then another 10, and then another 10. So we'll end up with a comma over there. So we just need to put in some zeros, and we'll see that what we get here is 0,000,321. This one here, again, what you've got is 9,687 divided by 10 squared. So we've got to take our 9,687 and divide it by 10 and divide it by another 10. So divide by 10, divide by another 10. Your comma is going to go there. So what you'll get is 0,09687. So you can see, for example, here that this number is a lot smaller than this number, because here you're dividing by 10 to the power of 4, which is a really big number, whereas here you're dividing only by 10 squared, which is just dividing by 100. Okay, let's just quickly go the other way. So what if I wanted to take a number like this one and turn it into scientific notation? Well, if I want it in scientific notation, I want it to be written as 2,5 multiplied by 10 to the something. So I wanted that comma to be over there, and so it's 1, 2, 3 places away from what it was, so it is 10 to the minus 3. We're going to have a quick look at how scientific notation can be used in calculations. To do a multiplication like this, scientific notation can be very helpful. So we're going to start off by writing both of these numbers in scientific notation. So the first one, it's 7,05 multiplied by 4, 5, 6, 7, 8, 10 to the 8. And for the second one, it's 3 or 3,0 multiplied by 10 to the power of 6. Now what we're going to do is we're going to focus on each bit. We're going to multiply those together, and then we're going to multiply those together. So if we focus on multiplying 7,05 by 3, remember to multiply decimals. You simply ignore the decimal comma, so we're cheating a bit, but we'll correct for our cheat. 3 times 5 is 15, and then here 3 zeros are 0, plus 1 is 1, 3 sevens are 21. But that's not our actual answer, because we cheated by simply multiplying by 100 to get rid of that comma, so we must uncheat by dividing by 100, and so what we get here is 21,15. And then multiplying 10 to the 8 by 10 to the 6, well, we know how to do that. It's 10 to the power of 8 plus 6, right? And that's going to be 10 to the power of 14. Now it'll be nice, instead of just having it like this, that we actually have it in proper scientific notation, right? This isn't scientific notation here because it's 21,15. And remember, in scientific notation, we only want to have one digit before the comma. So how do we get that into scientific notation? Well, we know that 21,15 is the same as 2,115 multiplied by 10. So we can replace this thing here by 2,115 multiplied by 10. So what we've got is 2,115 multiplied by 10, and then we've still got our 10 to the 14. And so what we've got is we've got 10 to the 14 and another 10, so that's going to be 10 to the 15. So written nicely in scientific notation, it looks like that. Okay, if we had to do something like this, there'd be no problem whatsoever if instead of the plus sign here, there was a times sign. Then we do it the same way as we did the previous one. Multiply the numbery bits, and then multiply the exponent bits, and then put it all back into scientific notation. But unfortunately, we've got a plus here. And we don't actually have any rules for dealing with addition when we are working with exponents, right? If we've got 10 to the negative 4 plus 10 to the negative 3, we don't have any rule. There's no exponent rule that helps us deal with that. And so the only thing that we can actually do in this case is move these numbers back into standard form and then add them as we've always added decimals. So let's do that quickly now. Putting this one back into standard form, the first one, we've got to go back 1, 2, 3, 4. So it looks like that, 0,00041. And then our next one, we've got to go back 3, 1, 2, 3. So we're going to have 0,0066. And now we've got to add those two. And remember, when we're adding, we just need to make sure we line up the comma very nicely. And then we add in the way we always have. And we get our answer. And we could, if we wanted to, write that into scientific notation, and it's going to be times 10 to the negative 3. We've been looking at scientific notation and doing our conversions by hand, but obviously we'd also like to know how to work with scientific notation on a calculator. So I'm going to take you through that now. If we're asked to write 5,32 times 10 to the 5 as a decimal number, i.e. not in scientific notation, this is how we're going to do it using our calculator. The first thing you need to do is just make sure that you're in the correct mode. So it should just, in that little place there, say math, nothing else. Okay, then it's simple. We enter 5,32. Use that times 10 to the x button, and then 5 for the exponent, and we press equals, and we've got our answer. So the main thing you need is this button times 10 to the x, and then you just straight after that put in whatever your exponent is, like in this case 5. So here we go, another example. Again, we check we're in the right mode, and then we simply enter 1.23. Use your times 10 to the x. This time we need that negative button and the 6, and we get our answer. So the only extra thing here is we use the times 10 to the x button, but because we want a negative exponent, we use that negative and then the 6, and we've got it. All right. Now, if we want to work with our calculator in scientific notation mode, we first need to change the mode of our calculator into scientific mode. So, shift, mode, and then we choose 7 for sci, and then we choose the number 3 at this point. I'll explain that to you now. Okay, let's go through it again. We do shift, then mode, then the 7, And now this next number where I chose 3, what is that about? Well, it really just allows you to decide how many digits you want in the answer. So I chose 3 digits, and this would be something like 5,32 times 10 to the 5. There's just 3 digits there. Whereas if I'd chosen 6, then I'd have something like 5,32410. That has got 6 digits in the answer. Okay, so now we've changed it into scientific notation mode. Notice over there now, instead of just the math, you've got sci math, and that tells you you're using scientific notation mode. All right, now we can go from a number in just normal decimal notation into scientific notation. How do we do that? Well, we simply put the number in and we hit the equals to sign. Now notice here we get 6,58 times 10 to the 5. And that's a bit unexpected because I was kind of expecting 6,579 times 10 to the 5. But remember, when I chose that mode, I said I only wanted 3 digits. And so my calculator is obeying me and giving me 3 digits. So it's rounding from 6,579 to 6,58, so it can just give me 3 digits. So if I'm not happy with it doing that rounding and I actually want more of the digits, I can just go ahead and change that in that mode. Let me show you how. So I go through the same process, shift, mode, 7, but this time I'm going to choose 5 because I want 5 digits in my answer. Now when I go through that process, I get 6,5790 times 10 to the 5. So you can always just go through the process of shift mode 7 for scientific notation, and then you choose whatever number of digits you want in your answer in scientific notation. So you can happily change it back and forth. Another example, if I wanted to write 0,000034 in scientific notation, I can do this on my calculator. First step is always just to make sure I'm in that scientific notation mode, otherwise it's not going to work. And then I go ahead and type in, and I press equals. Now notice here it gives me a fraction, so I just need to hit that SD button to turn it into the form I want. So the only addition in this example, when you doing for, numbers that are small little numbers, it's going to give you a fraction and then you hit the SD button to get it into scientific notation. All right, if I want to do a calculation like this on my calculator, again, first step is to make sure I am in that scientific notation mode. And then I simply pop it in, 1.45, use the 10 to the X button, and 3, and then 2.36, use the 10 to the X button, and 2, and then hit equals, and it gives me the answer. Now if I wanted to put that answer back into our regular normal number form, well, I just need to change back out of scientific notation mode and it will immediately turn it into the right number. So how do I take my calculator out of scientific notation mode? I proceed as follows. Shift mode, but in this case I'm going to choose 8 for normal mode and 2. And I'll get my answer straight away as 342200. So let's recap that. It's shift, mode, and then this time 8 because you want normal mode. It gives you a choice of 1 or 2. Choose 2 because 2 will turn bigger scientific notation numbers into decimal numbers, whereas 1 won't. And just a final little word of warning, you actually still need to know how to do the conversions by hand because your calculator has limitations. So here I've got my calculator perfectly in math mode and I want to write 1.23 times 10 to the negative 12 as a decimal number, I proceed as I've always done. Hit the equals to sign, and my calculator simply doesn't do the conversion. It leaves it as 10 to the negative 12. And why is that? Well, it's because 12 is a really big number, right? So there's going to be lots and lots and lots and lots of zeros here, and that's simply too much for the calculator, and so it leaves it in scientific notation mode.